and this is another edition of 3D Printing News Unpeeled. And today we're going to look at, well, kind of an essential phone. Marko Lazic has made the Offone. It's a 3D printed phone which has an e-ink display. So it doesn't have all the bells and whistles of the most of the phones that we, you and I, carry around every day nowadays. It's kind of pared down to the essential, but it can do calls, it can do text, it can do messaging, and it can even do Uber and apps, although I'm not sure how it does maps. And it's meant to be an easy-to-use, pared-down e-ink display phone that's really small and kind of very, very portable. He's kind of targeted at older people, but at the same time, it's easy to see that how many people, that many more people, like younger people, for example, would want to kind of have a permanent kind of digital detox. Yes, I want to be in touch with my friends. Yes, I want to be able to navigate, but I want to get rid of all the games and all the other silly stuff in my life. So I think, either temporarily, whether you're studying for exams or, maybe for a large portion of life, I think we may see some people will turn their back on the latest and greatest phones and turn to more pared down, more basic devices. Now, is this going to happen? I don't know, but many people unlock their phones between 110 and 150 times a day, which is like crazy amount of time. And if I look, every time I look at my Apple screen time, I'm kind of worried for myself and my future, let's say. So I think the Offone is a really great concept, this e-ink display, and I think that could really be a very promising thing for the future as well. The next thing is Tidal power. That's Lance McMullan, who lives in Juneau, Alaska, has made the Chinook 3.0, which is a tidal power device. Now, we know that people are using 3D printing to create tidal power, but Lance has come up with a very different way of doing this. It's basically making a tidal power device to attach to boats. And the idea is that this 45 kilo weighing device, you'll take it aboard your boat, and then once you're somewhere, you need some power, maybe for the electronics, for the microwave, for the radio, whatever, that kind of stuff. Then rather than using the diesel engine or a diesel generator, you can then use this tidal power unit that you just plop over the side of your boat, and then you can then use it. Now, I think it's a wonderfully inventive thing. What's really cool about this, from our perspective, of course, he's printing this on a Modix 3D printer. So he's taking a Modix big meter, which is a 980 by 1 meter by 1 meter build volume printer. It costs around 15K. It's not that expensive at all. And he's printing the parts of this device on that printer. So, if he wants to scale production, the print jobs will last a long time, of course, but if he wants to scale production, the path forward is quite straightforward, and he would just use his Modix in that kind of a fashion. So, I love this. What they're doing right now is they're making a bigger version, which is meant to have this one has up to 1.6 kilowatts power generation. That's ideal, so I don't know what it is normally over a certain period. But he wants to make a much bigger version, a 3.6 kilowatt version. And again, this is aimed at a niche. He's in Alaska. He's thinking, well, there's a bunch of remote onshore homes, and I'm going to make it for those homes. So not like now, tidal power often is for grids or for like a local community. He's thinking that there's somebody out there that has an onshore home somewhere on the seaside or on a river or something, and he could maybe use this kind of unit. I think it's a great initiative. I think it's fantastic. And then they're also going to make a smaller one, 20-watt one, that maybe you could bring on a dinghy or whatever. So I think it's wonderful. Maybe this is a new industry that a lot of people are going to be turning to. Medium format 3D printing, large format 3D printing to make power and wind generation devices. We're seeing a lot more of that lately, so I wouldn't be too surprised about that. And I can't wait to see more of that. The next thing is by Keith Brown. Keith Brown is an associate professor of mechanical engineering at Boston University. He's at the KABlab, I think it's called, and he's made something absolutely, completely fantastic. It's called Mama Bear. So Mama Bear is, they call it a robot. It's essentially a bunch of computers and things tied together. And essentially what it does is it prints a component. It then crushes this component, or it moves this component over to a crusher, then crushes the component, measures the energy absorption in that component, and then uses that through these Bayesian algorithms to design a new component, which it then crushes. So this is an experiment. Now, the really cool thing about this is the experiment was conceived in 2018. They started doing it in 2021. And since then, this thing has just autonomously been doing this experiment and conducting and making about 25,000 parts. Now, recently, the energy absorption readings that this thing has been getting has far outpaced many other researchers in the field, about 75%. Which is much higher than many other people are showing. So this actually proves that this approach could actually bear fruit. So the mechanics of additively manufactured architectures, Bayesian experimental autonomous researcher, Mama Bear, could really point to a lot of other things. Like imagine in 3D printing, we just all had, or all the filament suppliers had these robots that would conduct just the strength tests automatically and the build strategies tests and the G-code tests automatically on certain filament. Imagine if printer manufacturers were looking in this such an automated way and printed tens of thousands of structures to test the right infill. The right infill for lightness, the right infill for torsion, the right infill for remote control aircraft, I don't know what. And that would just do so much for us. And also imagine if you're a finite element analysis, FEA software company, and you just use this continually to test your algorithms and your assumptions and things like that. I think it's absolutely fantastic. And think of a lab where you make 100 experiments that autonomously run for a decade. Think of all the structures and all the things that these things will design and test that you may have never done. Think of all the counterintuitive, completely crazy things that they'll find. I think it's absolutely fantastic. The paper's been published in Nature Communications. And I think this is great news. This is something I think if you're a researcher, think about this, because there could be in your area a really optimized way to make a similar type experiment. This is it. This is 3D Printing News Unpeeled. My name is Joris Peels. We do this for